In this video, I will show you guys how to solve a quadratic trigonometric equations. So for this problem, we have find all angles 0 degree less than or equal to theta less than 360 degrees that satisfy the equation below to the nearest tenth of a degree. So we have cosecant square theta minus 9 secant cosecant theta plus 20 equals 0. So this quadratic equation, we can use substitution. So if few of you not really comfortable with trig function, then you can use substitution method. So I will on the side, I let x equals cosecant theta. So that means now for whatever cosecant theta right here, I will replace it by x squared minus 9x plus 20 equals 0. And I'm pretty sure most of you guys know how to solve this problem. You can use quadratic equations, or you can use factoring if it's factorable. So usually, personally, I like factoring method. So I will try to factor this quadratic equation. So if I factor it, I will do the diamond method. So diamond method, I will have 20 on top and negative 9 on the bottom. That means I'm looking for factors of 20. So on the side, I'm looking for factors of 20. So this can be 4 times 5, or negative 4 times negative 5, 1, 20, or negative 1, negative 20. And then now I will look for the pair of factors that can, when I add them up, it give me negative 9. And then the only pair can do that's this pair right here, negative 4 and negative 5. So that means I have negative 4 here and negative 5 here. And what can I do with negative 4, negative 5? So go back to x squared minus 9x plus 20 equals 0. It actually, negative 4, negative 5 can help me rewrite negative 9x as negative 4x minus 5x. And I still have x squared, bring down, and then plus 20 and equal to 0. Now I have 4 terms. I can use grouping method. So then I group the first and the second term and the third and fourth term. So first and second term, I have x in common. So I factor out x, and I have x minus 4 is the leftover inside the parentheses. And then for the third and the fourth term, you see that I have negative 5 in common. So I factor out negative 5. So then inside, for the remaining, I will have x minus 4 and then equal 0. So if I apply the distributive property, I will have x minus 4 and x minus 4 go one side. Okay, these two rewrite at once, and then the remaining is x and negative 5 go together in one box, and then equal to 0. Okay, and now I can solve it. So then I can have x minus 4 equals 0, or x minus 5 equals 0. And then I can have x equals 4, x equals 5. However, I'm not done yet, because x is just my substitution. The real one I want to solve for is the angle. So therefore I have to think about back here. I have x equal cosecant theta. So now I replace x again as cosecant theta equals 4. And like what I said earlier, in the previous video. So when we have cosecant theta equals 4, usually we rewrite it in terms of sine. So now that means we have sine of theta equals 1 over 4 because it will be the reciprocal of cosecant. And similar to that, we have cosecant of theta equals 5, and that means sine of theta equals 1 over 5. Okay, so now for each of them, we will solve them. So then we have, I bring it to the side right here because I run out of space. So then for sine theta equals 1, 4. So sine theta equal 1, 4. And I do theta equals sine to -1 and then 1, 4. So when you put it into calculator, you have theta equals 14.5 degrees. Okay, but we need to sketch the angle on the unit circle to give us the idea what is the accurate angle. So if I sketch it, so from here, from this step right here, okay, I can sketch the angle on the unit circle. Just give me the idea where it should be located. So when I have sine theta equals 1, 4, that means I should have a positive sign. And which quadrant will give me positive sign? First quadrant and second quadrant, because I'm looking for the positive part of y. So now my angle will be right here and the other angle will be right here. So then I have two angles, the red one and the green one, because I need the angles in standard position. Go back to the direction again. Your angles have to be 0 degrees less than or equal to theta less than 360 degrees. So therefore that means when you put your answer for the angle, it have to be in standard position. Okay. So then the red angle in the first quadrant, and if the reference angle is 14.5 degrees, then the in the first quadrant the reference angle will be equivalent to original angle. So my red angle is also, okay, red one is also 14.5 degrees. Now my green angle in quadrant number, the second quadrant. So therefore, in order to find the angle, the green angle in standard position, I will take 180 minus 14.5 degrees, and that gives me 165.5 degrees. Okay, so just for the first solution, first one, sine theta equals 1, 4, I already got two solutions. The first one is 14.5 degrees and the second one is 165.5 degrees. Okay, and then I move up here, and then for this, don't forget, you're not done yet because you still have the second one is sine theta equals 1/5. And again, from this step we can sketch on the unit circle, sketch in an angle on the unit circle. So then I have one angle look like this, one angle look like this, and the other one also look like this, because I'm looking for the positive part of y. So then I will have two angles in standard position. The first one is the red one and the second one is the green one. Okay, and then the yellow angle right here, just the reference angle. And it's sometimes the reference angle is not the one you want to looking for. Okay, but if the reference angle in first quadrant, then it will become your solution also. All right, so if you put theta equals sine -1 1/5, you will get theta equals 11.5 degrees. And like what I just said, because our red angle is in first quadrant, therefore it's equal to the reference angle. So the red angle is also 11.5 degrees. For the green angle, because it's in second quadrant, so therefore we will take 180 degrees minus 11.5 degrees to find the green angles, and we will get 168.5 degrees. Okay, and these two also are our solutions. So for this problem, we have 4 solutions. It's 14.5 degrees, 165.5 degrees, 11.5 degrees, and 168.5 degrees. Hopefully in this video, I just help you guys understand about how to solve quadratic trigonometric equations.